Next topic in the bevel gear is the terminology of bevel gear. In terminology of bevel gear, what is given here? Let we are going to see. We are going to understand what are the different terms we use for knowing the bevel gear. So this is the figure of bevel gear where we can find terminology and these are some terms. So I shown you each and every term at one split only. Pitch cone. This is the pitch cone. Okay, the, the line which is generated here. Okay. It is an imaginary cone and its center is O. That center is known as the cone center. Okay, here is the cone center. So there are so many things. Let's see this cone distance. Cone distance is nothing from this O point to this A point. Here it is shown. Okay, this is the cone distance. That is the imaginary point. Hmm. Then the pitch angle. We can see here this is the addendum line. This is the pitch line, and this is your dedendum line. Here it is given. This line is pitch line, addendum line, and this is dedendum line. So the pitch angle is what? This gamma. That is from pitch to this center line. You will get this angle. That is the gamma angle. It's an imaginary part. Then the next is the addendum angle. Addendum angle is what? The angle between these two. That is the center line, pitch line, and the addendum line. So that angle is addendum. Same dedendum angle is what? The angle between this pitch line and the dedendum line. And that is the dedendum angle. Phase angle is what? The angle from center line to the pitch line is your phase line angle. Root angle is what? The angle between the center line and the dedendum line is the root angle. Okay, this part is known as phase here. Now in cone, one more thing is that is the back angle. So this is the back cone angle because the front part is the spherical part. We can't use it for designing the gear. That's why the whole procedure is done with the help of back cone. We are going to see in the next slide also. So this is the imaginary cone and that is the back cone which is having a flat surface. So back cone distance is what? This to this C from this big C point, this RB, that is the radius RB, and this continues like this and it's create a flat surface. So these are the terms which we used in the bevel gear. Now let's understand these terms simple way. Okay, these are the things. In this spherical way, the bevel gear is designed. If you design the cone, so cone is nothing but a spherical part. You can see this spherical, this pitch point, this back cone, and this. So this spherical part, we can't design the gear teeth on this cone. So that's why a flat surface is needed. So flat surface we get here at the back side of the cone. So this is the back side of the cone. So the teeth can be generated here. So these are the imaginary teeth, or you can say the virtual number of teeth, just like the helical gear. So these are the virtual number of teeth. Now this teeth, based on this only the beam strength and wear strength equation is generated, and that is known as the thread goal approximation. Okay, so the tangent to the sphere, this tangent to the sphere generate a close approximate surface of the sphere, and that is the flat surface. On that, how we can find it out? So this is the figure which we have seen previously. Based on that, spur gear having z dash as the number of teeth on the gear. Okay, now this is the bevel gear having dp and this is dg. Now let's resolve it. Z dash will be what? 2 times rb upon modules m. So m is the module, z is equal to what? D by m, that is for here for the bevel gear, z is equal to d by m. Now from 1 and 2, that is a and b, we get z dash upon z is equal to 2 times rb upon capital D. So a line AB is drawn perpendicular. Okay, a line AB is drawn and here drawn a perpendicular OC. OC. Okay, AB is there. This is perpendicular line for this. From triangle ABC, this AB and this C point. So here it is in this figure, it is A, B and C. So from A, B, C, what we get here, that AB upon AC. So that is nothing but sine of 90 minus gamma is equal to d by 2 upon RB, because AC is RB and this AB is d by 2. So this is the things we get here. So RB, the value of RB you can calculate with the help of this relation d upon 2 cos of gamma. Now if you put this value in the above equation, that is here at this point, you will get z dash is equal to z upon cos of gamma. So this is the next equation which you get here. Now tan of gamma is equal to what? It is nothing but AB upon OB. So we solving it get mzp upon mzg. You can say zp upon zg. Okay. So tan of gamma is what? Zp upon zg. These are the formulas which you needed. So it can be proved that tan of, this is the capital letter G. This letter is known as the capital letter G. G. J. G. H. E. G. Okay. A cyclic word is there. Okay. And gamma plus key is equal to pi by 2. So the cone distance will be what? A0 is equal to AB square plus BO square. And that is nothing but dp by 2 square plus dg by 2 square. This is the center distance by which we can get it. So this is how we can get the formula for this. Okay, these 2-3 formulas are needed for the solving the or design the gear. Okay, thank you.